Okay, so this is page 3. We're going to look at here that the carbon growth rate of carbon-14 is proportional to the amount present. We also gave you that the half-life was approximately 5,700 years. Okay, so because it's proportional to the amount present, what that means is that we have dy dt is going to equal to some number k times y. Okay? Remember, we then have to separate, and so we get dy over y is equal to k dt. Now I got to integrate that. So when I find this antiderivative, it's going to be the natural log of the absolute value y is equal to kt plus some constant. So y is going to equal ce to the kt. So that is my general solution. Okay? Now, so that was this is our differential equation that models the growth. So now it says write the equation which models the amount of carbon-14 remaining. So I want you to think about it. Never really specified how much you needed or how much you started with. So we're just going to say at time 0 we had 10 units. Okay? So that means C is 10. Okay? So now we're going to use the half-life and go find K. So the second point we're going to use then is at 5,700 years, half of it remains, so we're now only going to have 5. So now what I'm going to have is, so C, we should have said C was 10, sorry. So then what do we have when we plug it in? Is we get 5 is equal to 10e to the negative 5,700 k, or e to the negative 5,700 k is equal to 1/2. Okay, now I can't unfortunately get the calculator on the screen, so that does make this a little bit more complicated as I'm sorting through all my pages here to make sure I get the right one. Okay, so if I then solve it, k is approximately 0.0001216, and that's going to be negative. Okay, so what is our equation? Is going to be y is equal to 10e, bless you, to the negative 0.0001216t. Okay, and then that's assuming we started with 10. So we could have started with 1, it didn't matter. Okay, for part C, it says if a sample has 22% of its carbon remaining, approximate how old it is. Well, 22% of 10, if we multiply it times 0.22, gives me, you have 2.2 remaining. So we're going to say then that 2.2 is equal to 10e to the negative 0.0001216t. Okay, and then I got to go solve it for t. So if I do that, it's really 0.22 is equal to e to the negative 0.0001216t. And if you solve that for t, you get that it's approximately 12,451 years old. Okay? And that's our third one. Okay? And that was part C. So this was the answer of part B. All right? All right, so now let's go on and do number 9. So this is an Euler's method question. You're doing 2 iterations. You're starting at 3 and you're ending at 3.5. So your delta x then is going to be, the difference between those two is 1/2. But then we have 2 iterations. So I got to divide that by 2 and I get that it's 1/4 or 0.25. Okay? And that's our delta x. So each time we're going to move to the right, 0.25. So now we got to go figure out how much we're moving up. Well, we know that our change in y is always equal to our slope times the change in x. Okay, so we are starting at the 0.31, and I'm going to go plug everything in to our differential equation, which is right here. And when I plug that in, my change in y is going to be my slope, which is 1 minus 3 over 2 times 1, and then that's times 0.25. So I actually get negative 2 over 2 times 0.25, which is just negative 0.25. So in the first iteration I went down 0.25. So where am I at? Well, I added 0.25 to 3, so I'm at 3.25, and then I subtracted the 0.25, so I'm at 1.75. Okay, so now we need to do another iteration on that point. Okay, and my change in y is now going to be 0.75 minus 3.25 over 2 times 0.75 times our change in x, which is 0.25. So I just again plugged it up here. Okay, and if I work that out, I get negative 0.417. So my final point, or it's 416 repeating, is at 3.5. If I add the negative 4.417 to this, I get 0.33. No. I get, I'm sorry, my y value up here was at 1, so that's going to be at 0.75. Sorry about that. So when I get down here, it's going to work out to be 0.33. So my final y value is at 0.33 using Euler's method, 2 iterations. Okay? All right, last one is we're going to find the equation of the tangent line at 3,1 and use it to approximate 3.5. So we're doing the same thing as number 9, but we are not doing Euler's method. We're just doing a single tangent line. So we got to go find our slope. And our slope is going to be y minus x, which is 1 minus 3 over 2 times 1. And that slope is negative 2 over 2, which, I'm sorry, negative 2 over positive 2, which equals negative 1. Okay, so what's my equation? Is y minus 1 is equal to negative 1 times x minus 3. Okay. So now I'm going to use that to approximate. And I'm going to go plug in 3.5 there. So y is equal to 1 minus 1 times 3.5 minus 3. So it's really 1 minus 0.5, which ends up at 0.5. Okay, clearly these are not the same, and they wouldn't be the same, because the second one would be true if we did an Euler's method, 1 iteration of 0.5, we get this answer. Okay? Hope this helps on the first 2 questions on page number 3.